Hi, my name's Derek and you're watching part 6 of the ActionScript game programming tutorial. Today's tutorial will show you how to create a tile map. Just before we get right into the code, let's have a quick look at the software that we're going to be requiring for this tutorial. We'll need either Adobe Flex or Adobe Flash CS4, or CS3 will work too, so either of these two editors will work. I'm going to be using Flex because I like its code editor a lot better. It has a really nice code editor. The other thing we're going to need is an image editing program of some kind, so I like to use the GIMP. It's not as good as Photoshop, but it's pretty good for a free program, so I'll leave that up to you. Last but not least, we're going to use a program called the TAT Tile Map Editor, or TAT. I'm not sure how you say that. It's a really good freeware program that you can download from the guy's website. The URL is pretty crazy, so if you just want to do a Google search for TAT Tile Map Editor, you'll get there. Download it and install it. If you have issues running TAT Tile Map Editor after you run it, just head over to java.com and grab yourself the latest version of their runtime and install that, and it should fix up your problem. I had an issue running it too because I didn't have the most recent Java runtime. So just before we begin, I'm going to be showing you a tile map image that I made in GIMP just using the pencil tool. It's just very simple because I'm really not an artist, I'm a programmer, so it's just to demonstrate the technique to you. As you can see, it has 3 tiles. They're all 24 by 24. It's very important that all your tiles are the same size, so use the grid control in Photoshop or GIMP to ensure that they stay the same size. My size for my tiles is 24 by 24. It's just the size I decided to go with. So I'm going to give you a quick overview of how to create a level in TAT that you can load up. TAT exports its tile maps as XML files. It actually exports several XML files, and I'm going to be showing you how to load those up and actually use the info in them to show this stuff in Flash. So we're going to create a total code implementation basically that parses these XML files. So it's really easy. All you do is create a new project, file menu, new project. So we're just going to call this one test underscore tile map. Very easy. Actually, you know what? Let's just call it test, just to make things really easy. And the very important thing that you need to change there is your tile size, because it could be anything. So we're going to use 24 by 24. Just because I happened to choose that size earlier. And that's it, just hit OK. Now, we have an empty project here, so what we need to do is we need to populate it. So what you do now is you go to the project menu, and you create a new tile palette. We need to start with a palette so that we can load things into that first. So the name of the palette is not really very important. We can change that later on if we want. We're not even going to care about that name really in our tutorial. In a real game, you'd want to have an interesting name like backgrounds or wood palette or whatever. So we're going to add an image to this palette, and we're just going to use that image I showed you before, tilemap.png. So it's very important to save your files as PNG because TAT only supports a limited number of file types. So just check that it says that it's loaded up down here, and you should be fine. And also make sure that you've got the split option selected, because that's the sort of the default one. But just make sure it's selected, otherwise you'll get some pretty crazy results depending on what your image looks like. You can use, I recommend going through TAT later on and checking out what all these other things do. They're also quite useful for some levels. So this is our palette, and as you can see, it's actually split it up into our 3 tiles for us. So these are the 3 tiles we now have. So it looks pretty small because this is a fairly high-res video. But you can see we can make, just with these 3 tiles, we can make a very interesting level. So the next step is to go back to the project menu and create a new tile map. This is where we're actually going to place our tiles, and it's quite important that we give it a short name because we're going to load a file with that name later. So we're just going to call it map, just to keep things simple. And we're going to make it pretty big, so this is how large the map is going to be in rows and columns multiplied by the size of your tiles. So 10 by 10 multiplied by 24 will give you about 240 pixels, which is pretty small. So let's make it interesting. Let's make it 100 by 100, which will give us a size of about 2400 pixels on each side, which is a fairly big size. That's much bigger than most monitors I've used. So that'll give us a fairly large thing. This is actually quite a small level in most games. This would be a very small level or even a boss level. So we're just going to start simple and start with something small. But it's very, very easy to make huge levels with this program because of the way it works. That's the whole idea behind tile maps. Alright, so now we've got an empty level. So all we really need to do now is just click on the tile we want and choose the Draw Tiles tool and just click and drag or click or whatever. You'll get the hang of it. It's very intuitive. So you just you almost paint the tiles down just like that. So let's make something that the player can stand on in the top corner. and then we'll just make a little bit down here, and just so on. It's really, really easy. So there's a whole bunch of other tiles we also have here that we can use. Let's put some of these guys along the top, you know, just things like that. And eventually you'll end up with quite an interesting level if you keep going like this. So this is actually a really good tool. I'm really not going into much depth about what you can do with it. For instance, it has like area selection tools and things like that, which are really, really useful. So you see you can copy and paste like in any decent program. I'm just going to use paste tool right there with Control V, just like any old, just like Photoshop, you can paste things to your heart's content just to keep things interesting. And let's draw a few more tiles. You've also got a fill tool, which is really useful. So I just on the wrong tool. Alright, so I'm just going to draw some more of these guys, just so we can check out the scrolling later on, because we want something that's fairly big to demonstrate that we are actually moving through it. Control C, Control V, and I'm pasting it. As you can see here, I'm going to paste a whole bunch of these guys. We can jump around on them without character. There's going to be no real character in this tutorial, but you'll be able to get the idea of what I'm doing here and why I'm doing it if you've ever played a game like Mario, for instance. So now all we need to do is we just need to save it. Now TAT saves out a zip file, which is a bit of a problem for us, but it's not that big a deal because we can just extract the zip file using WinRAR or WinZip or whatever takes your fancy. So that's it. That's how you create a tile map. That's all you need to do. So the next thing we need to do is just to extract that zip file we just saved. We're only really interested in 2 of the files inside it, and I'll show you which ones they are. So that's the one we saved out of TAT. So I'm just going to open it with WinRAR. In fact, I don't even have to open it. I can just extract it right here with WinRAR, which is very convenient. You can use WinZip or any sort of zip type program to do this job. And now, as you can see, it's extracted it all into this folder. So if we go and look in there, the only 2 files that we really need are map.xml and tileset.xml. These other files, as you can see, it's actually put the image here too. So what the real rationale behind this zip file thing is so that you can just have one file that represents your entire project, which is useful for TAP, but for us it's a bit of a pain. So we're just going to copy these 2 files and we'll come back to them a little bit later. So what I'm going to do is I'm just going to stick them on my desktop so that I know where they are. So we're just going to leave them there for now. Alright, so let's get Flex going. So the objective behind this tilemap library is to create a package that'll let us load tilemaps up into pretty much any Flash application. It's designed to be reusable, and it will also be designed to work with any sort of loading bar you have. So we want it to load asynchronously. So a fair amount of complexity is going to come from that, but the end result will be really nice because you'll have a nice loading sort of sequence and everything. So let's get right into it. Once you've got Flex loaded up, let's create a new project. So make sure it's an ActionScript project. And we're just going to call it test_tilemap for simplicity. Now take careful note of where this project is going to go, because you're going to be going into that directory pretty soon. And then once you're happy with that, just hit finish. Now Flex is going to create a bunch of things for us. Most importantly, it's going to create an ActionScript file, which is the entry point of our program. And that's going to contain a class, which is our document class. So the very first line of our program is line 7, which is the constructor of that document class. And the document class itself is a sprite too. So that's pretty useful. So there's already a lot of things done here for us. We don't really have to do very much more. We can just get right into our code. So the very first thing I'm going to do, just to make sure that all of this works, is I'm just going to create some progress text. And we're going to be using this a bit later too. Just sort of show what the loading progress is. So the first thing I need to do, obviously, is I got a bit ahead of myself there. I need to create a member variable that can contain this. So I'm going to call it m_progress text. So it's just going to be called that. I'm not going to make it equal anything quite yet. Alright, there we go. And it's just going to be, I'll just do autocomplete. It's very, very good code editor. It really knows what you want to do. So we're just going to create a text field. Just like that. And we're just going to sort of try and stick it in the middle of the screen. So we're just going to use the stage's width and height. This, because we are inside a sprite object, every sprite object has a stage member which points to its parent stage. So we'll do the same. So we're just going to take half the width and half the height of the stage. It's not perfect, but it'll just do for now because it's just something quite rough. And we're just going to give it this text, just something simple. And finally, we just have to do an add child onto our stage. There we go. That's all we need to do. So let's just debug and run that and make sure everything's working. Yep, that looks fine. As you can see, our loading text is right there. Alright, so let's keep going. I'll just get rid of all that. So the very first thing we need to do is, since we're going to be creating sort of a package, is we're going to create a package by right-clicking on the source folder and creating a new folder. And we're just going to call it tilemap. That's going to be the name of our sort of tilemap package. Inside here, we're going to create a new class, as you can see, and we're going to call it tilemap2. So just to make it really easy for anyone, third party or whoever is using this, as you can see, it's created the class for us, which is really nice, and it's given us a constructor too, which is convenient. And now let's start using this. So what we're going to need to do, first of all, we're going to actually need to think about how this class can be used. So we're going to need a few different things for it to work. So a tilemap will need something to display on. So the very first thing it'll need will be a parent sort of object, and in this case it'll just be the sprite object that I was discussing earlier, this sort of global sprite, the document sprite image. So we're just going to give it that, just like so. The first argument of the constructor is the sprite. So we don't actually have a using here, so we're going to just auto-complete it, and as you can see, Flex puts that in for us, which is handy. We're going to need a couple of other things as well. What we're actually going to need is, if you recall those two XML files that we had earlier, map and tileset.xml, we're actually going to be able to tell the tileset where they are or what their file names are. So those are the two very important things we're going to need. So I'm just going to call them tileset path, and they're both just going to be strings, and map path. The reason we have this instead of just hard coding the names is so that later on the third party can just create a tile map pointed to an arbitrary map somewhere, and you can have multiple tile maps if you wanted to, which is very convenient. So we're just going to create little member variables for these guys. They're all private, obviously. Just like so. And I've actually just remembered that I didn't put that type into the progress text in the last one, and we wouldn't have had the import happening either. So there we go. Let's just fix that up. My mistake. Alright, so we just want to complete this by adding the other two member variables. And there's just a string. They're just all strings. So that's really easy. And then we're just going to assign these in the constructor. They're sort of going to hang around for the lifetime of this object and give us info when we need to load stuff. So we're just going to do that. Oh, I assigned it the wrong one. It should be parent sprite. This one is the tileset path. Yes. And last but not least, the map path. Very easy. And now all we need to do is just go back into our sort of host application for this class and create an instance of this tile map. So very easy. We just go create that. We'll give it a name like m_tilemap, and it will be a tile map. As you can see, Flex already knows about it, and it'll give us an import. Very, very convenient. So there's the import that it just gave us too. So we obviously need that to create one. And then we just create the map. And it knows about the arguments too, which is really handy. So the sprite we're going to give it is the global sort of document sprite, which is this. We're already in the constructor of that sprite. And the tileset path will just be tileset.xml. And map.xml will be the map file, because they're the files that I have on my desktop. So I'll show you these. And in a moment we're going to move these to a place where it can find them without needing to even know which directory they're in, using the automatic sort of current directory feature of the Flash application, which is very handy. So now that we've done that, what we need to do is actually move these files into the right place. So what I'm going to do is I'm just going to cut these files, and I'm going to show you where you should put them. Now this is only for the purpose of this tutorial. Any experienced programmer watching this is going to groan when he sees what I'm about to do, but it will do fine for this tutorial. I'm actually going to stick them in the bin debug directory, which is created for us by Flex when we created our project. As you remember, I told you to remember where our project went. Well, underneath that folder there's bin debug, and that's where our Swift is, which Flash or our Flex builder would export that for us there. So as long as we put our files in the same directory as the Swift, we don't need a directory to look them up. We can just use their file names directly. But this will break if you use a release configuration, for instance, or there's a number of other things that could cause this to break. So it's purely for the purpose of this tutorial that we're doing this. So normally you would want to actually have this deployment set up a bit better than this. But we're not really showing you how to deploy applications in Flex. It's only about tile maps. So let's get moving. So the very first thing we need to do is load that tileset.xml file. Now the reason we load tileset.xml before map.xml is quite simple, and that's because map.xml has a dependency on tileset.xml, and I'll show you what that dependency is. So we look at tileset.xml first. Now the format of these files is very simple. They're just XML files, and the tileset file contains a series of tilesets. So in our case we only have the one, but you could have a number of tilesets. In most games we'll have several. As you can see, it has plenty of info about what that tileset contains, and we're going to use this information in our program. After that, it has a series of unique tiles. So these are sort of, you could call them templates. These are the tiles that are actually used in the map, as opposed to tiles that potentially could be used in the image. And they each have a unique identifier, as you can see here. So that identifier is very important, that number. We'll come back to that. We'll see that how that's used in the map. They also say which tileset they belong to, which is very important too. We're not going to be using the rest of this info in our tutorial, but it is essential for creating a full-fledged game. So it's pretty obvious what it is just by looking at it to any experienced developer, but I'll do another tutorial on how to use these advanced features later on. So now that you know how the tileset XML looks, I'll show you why the map.xml file depends on it. So as you can see here, we have a tile map with a background color, number of layers, and the rows and columns, which is a very important figure which we're going to be using to compute how big things are in our map. It also has a tile width and height, which is a bit redundant. So next up we have a series of layers. So we only have one layer in our application, but you could have as many as you want, and they're used for transparency effects. So you want to have things seeing sort of see-through tiles that you can see through other tiles, and things in front of the player and things behind the player. You use those layers. Each layer contains tile data. Now tile data is not very intuitive at first glance. You look at it and it's just ones and zeros, but really what's going on here, if you look more closely, is it's referencing tile indexes. So these indices are actually the same as these ID numbers. So it's really saying just use this object in this spot in my sort of grid of tiles. And this grid, the number of items in this grid, the number of indices, is exactly the same as number of rows multiplied by the number of columns. So that will tell us how many to load essentially. And we're also going to use that info to create an array of our own that contains exactly this information. So that's why we load tileset.xml first. So let's get back into our code. So let's begin loading the tileset.xml file. We're going to use Flash's built-in URL loader and URL request objects to do this, because they're the asynchronous loaders that we need. So they're really easy. All we need to do is create a couple of variables. They're just temporary. We'll call them URL request and URL loader. And URL request, just use that type over here. We'll just create a new one. URL request just tells it where to get a file from, so it's really straightforward. And its only argument is a string, which obviously contains the path to the file. The URL loader is even simpler. I'll just import that. It doesn't take any arguments. We actually have to configure it slightly differently. So the first thing we have to tell it is what type of file it's going to be loading. So that's just going to be a text file. So URL loader dot, it doesn't like that. URL loader, new keyboard, so please excuse me. And what we want to do is tell it what its data format is. So that's going to be picked from the list of available data formats in URL loader data format, which also has to be imported. And the one we want is called text. So that's really easy. Next thing we need to do is create a function that gets called when our file is finished loading. So we can really easily do that by just calling add event listener. And the event we want is event.complete. And we're just going to create a function name. We haven't made the function yet. We'll make it in the next step. We'll just call it that. We'll just call it URL loader underscore tile set. Last but not least, to get the ball rolling, we just call load. And then we give it the request we created above. And that will actually start loading the file. So it may take a while to load the file. And as you can see here, we haven't made the function yet, so it's not happy with us. So what we'll do is we'll just make that function. And the only argument that these functions take is an event object. So we'll just call it EVT, and it's of type event. Pretty much all of these event sort of handler functions take that. And in here, we'll just put a trace for now. And we know what the file name is, so we just use m underscore tile set path. It's never going to, this function is never going to be used to load any other file. And let's just check that that works. We'll run it and make sure that that works. And as you can see here, it's completed loading tileset.xml. So that's great. So let's stop that. That means it's found the file happily and everything's okay. So before we can actually start passing the XML in tileset.xml, we just have to go and fix up some little malformed XML. As you can see here, that / is bad. This whole element means that you shouldn't really have a / there. This XML is malformed. You should only have the / here, because that closes out the element. But it's very easy to fix this, luckily for us, just by using a little regular expression I made. I'm not going to go into too much detail about how it works. Suffice to say that it gets rid of that / that's been pretty troublesome for me. I couldn't really figure out what it was. It was kind of hard to see. When you do see it, it's pretty obvious though. So there's some great NetTuts tutorials about how to use regular expressions. So if you're curious about how this works, just go and grab one of those. So for our purposes, all we really care is you have a function. It takes a string which contains the entire XML file, and it returns a string which has got that XML file minus the troublesome slashes. So all we need to do is use that function. So when our file completes loading, the event argument contains our XML file in its target data. So event.target.data, that's our XML file right there. It's a big string. All we need to do is just call fix tile map to XML, and it auto completes for us, and give it that string. So it'll automatically be converted for us. And then we can create an XML object using that string. So we can create an object like myXML and just use the XML type, which is a very powerful XML parsing object all of its own. We create a new one, so new XML. And the only argument to this new XML object cares about is the XML text. So just stick it in there, and that sort of little sequence will give us a XML that can actually be loaded. If we didn't do this fixed tile map, we'd actually get an exception because of that /, because it would be malformed XML. So if we just go back to our XML file for a moment and have a look at this tileset.xml, what we want to do is create a class to represent this element. This element will define what's in our tile set as opposed to which tiles are in it. So that's the first thing we're going to do, and what's actually going to happen is the class that represents this element will be responsible for loading this image. So we'll centralize that responsibility in just that one class, which will make a very nice clean design. So that's really easy to do. All we need to do is go into our tilemap package in the navigator and add a new class. So a new ActionScript class. And we're going to call this one tileset. Now once you've created the class, just an empty class, we'll have a look at the diagram that shows you how this whole thing is structured. So what we're planning to do is to have a new number of tilesets, potentially a number of tilesets. We're going to have a member variable in the tile map object, which contains these tilesets. So we're going to have a number of these tileset classes, one for each tileset, and they're going to be stored in a dictionary so we can look them up. So now that we have this class, all we need to do is make a new instance of it for every tileset. So that's really easy. We can use the XML parsing abilities of the XML object in ActionScript 3 to do that. And it's really easily done. All we need to do is use a for each loop. So I'm creating a variable. This will be our iterator. It will contain each one of these things in sequence. It's an XML object too, but a much smaller one obviously. It's only going to contain data for this one element. It's only going to contain this instance of the element. and that's going to pull its data from the tile sets member. Now this will take a little bit of explaining this, what I'm doing here. It's actually really simple. As usual in any C style language, you have to do it sort of from right to left to figure it out. So what's going to happen is here, I want element 0, which is the very first element of something, and that something in this case is the tile sets element. So I'm using the E4D sort of XML parsing syntax here. This is not a member variable or anything like that in my code. This is actually part of the XML. So if you go back and look, you'll see there's an XML tile sets element. So that's what this is referring to, this dot tile sets. And the way that this works is the myXML object actually exposes this as a sort of pseudo member variable, and we can do things with that. So once we know that, we can actually say, okay, I want the very first element in here. So I want the very first element. So just give me that. I actually want the very first tile sets element, not the first tile set element. So it's going to give you that, and inside that, we're going to iterate through every tile set here. What's actually going to happen is it's going to iterate through every single element that is in here, regardless of its name. But that's fine, because we only ever expect to see tile set elements. So that's good. So now, for us, probably the most interesting thing here is the tilemap.png, the file name. So that's the first thing we're going to pull out of these elements, just for testing purposes, just so we can trace and make sure that everything is right here. So I'm just going to create a little variable called fn. I'm just going to hold this file name, and it's just a string. And this is where the syntax gets even more crazy. It's quite interesting how they did this, but once you get used to it, it's very powerful and very concise. The only thing I wish is that it had autocomplete on it, but that's okay. So I've created a little statement here. So what I'm targeting is this guy, this element. So on my part, this is an attribute, not an element. So I want this attribute. And when you want an attribute in this E4D syntax, you use the at operator combined with the dots. The dots literally mean do a subrecursion into these elements and find something for me. So once again, we're going to start off with the tile set, which, as we discussed earlier, is one of these elements. So you're looking at this whole element right now. And inside that element, which is what the dot means, like go into that element, I want an attribute, which is indicated with an at, probably because the names are similar. I want an attribute called file, just literally file, exactly like that. And if you look here, we have an attribute called file. That's it right there. And I want that as a string, because what this whole thing is actually returning is an XML object, which is useless. It's not a string. So convert that to a string, and finally turn that into a real string object. So literally, you're just going to grab the string out of there. And we're going to do more things very similar to this later on. So it's important to get this syntax down. So in there, you want an attribute called file. So we're going to copy and paste this quite frequently. So let's just trace this and see if we're actually parsing our file right. So we're just going to say found tile set element using image file, and that should allow us to trace the file name. And when we run that, we should get a log telling us what the file name is of that first element which we are loading. Just take a sec, and if we go back into Flex, so as before, it's completed loading, and now we've got a new thing. We found a tileset element using image file tilemap.png, which is info that's come straight from this XML file. So that's great, that's working fine. So now that we're loading up the tileset element correctly, we can actually go and begin populating our tileset class. So that should be really straightforward. All we want to do is just add a member variable for each of these guys. So we want a member variable for those three to begin with. And we're also going to need to bind it back up to its parent tilemap class too. So let's get started with that. So first of all, what we're going to need to do is actually create these member variables. We're just going to add them right to the bottom. So we're going to start out with the parent object, which will be just called m_tilemap, and it will just be a tilemap. So there's going to be a parent-child relationship here. So let's add that guy in. We're going to have a few arguments here, so we're going to put it on multiple lines. And what we'll do is we'll just call this one tilemap. And it'll just be a tilemap like that. So let's just do that one first. So all we need to do is just set it. So tilemap equals tilemap like that. Just like that. So the next thing we'll need is the path to the string, which will have been pulled out of the XML earlier. So we'll just call that file path. That'll just be a string. And we'll also need the tile width and height, which we're going to pull out of the XML in a moment. And they're just integers. So we're going to pop these, we're going to pull those out of the XML too. So let's create variables for each of these guys. So file path will just have a very similar name, and it's just a string. And likewise for the other guys. So tile width and height. I left out the var, and they're just integers. And that's in pixels, so it's quite an important comment to make because it's not very clear from the name of the variable. Perhaps we could call it, have named the variable slightly better, but that'll do for now. Oh, my apologies, I'm used to Visual Studio where Control W means select whole word, which Flex unfortunately Eclipse really doesn't have. We just set them up. And then we just do that, very similar to the previously. And this will all become important later on. You'll see why I'm going to this much trouble to save all of these things. And they are going to be used quite extensively in our later work with the code. So the structure you'll get to see why I'm going to all this trouble. And now all we need to do, now that we have this basic skeleton of a class that saves some things, is we go back to tile map. And all we need to do now is just pull those out of the XML. So what I'm going to do is I'm actually just going to create a new tile set. In a moment I'll demonstrate to you where we're going to put this new tile set, but for now we're just going to sort of create it. So in here we need a tile map, which is this, because we're already in a tile map object at this stage. And then we need the path of the file, which as we've discussed is just fn. That's this guy. So that's the image PNG file that we looked at earlier. Unfortunately it doesn't autocomplete once you get out of there. So I'll just do this. And then we need the tile width and height, which is a little bit more tricky. We pretty much have to do almost exactly the same thing as this. So what we're going to do is, once again, we're just going to use that E4D syntax to just grab them out using their names. And this constructor is actually starting to get quite long, so I'm going to put it on a couple of lines just to make things a bit clearer here. So what we want is to just change that. Because they're all attributes of the same element, we can just do that. So as you can see, I'm using the tile width here, very similar to the way we pulled out the file name. And because we can use that syntax to pull out the file name logically, we can do the same thing with these attributes, tile width and tile height. So that's what I'm going to do here. So they're very similar, they just have slightly different names, really. And that's it. So that will create a new tile object. So that's going to work fine. That'll represent the data that's in the XML file at least, but we need something more. What we actually need is an image object to represent what is loaded by this file name. So that's really easy to do. We're just going to pop that in here, and we're just going to create an image. We'll just call it m_image, and all of that is just a bitmap data. So just like that. So bitmap data takes a bit of explanation. We're going to just put in a comment here. So it's the bitmap containing all our tiles. So that's the bitmap we discussed earlier. That's this guy. I've actually not copied it correctly, so I've just noticed that we will actually need to place the bitmap in this folder too. So what I'm going to do is I'm just going to go back into my documents folder in the tile map that we created earlier and just create that image we discussed. So we're going to go back and let's just pop that into that bin debug folder from earlier. Otherwise it's actually not going to be able to load it. Even though it's loading the XML files, it wouldn't be able to find the image. So once again, it's the same deal. Since the image is in our runtime directory, we don't need to know the directory. So we're just going to be loading that image up into this bitmap data object. And I'll demonstrate to you how that works in a moment. So it's very easy to do. All you really need to do is create another URL loader, but slightly different this time. It's not exactly the same. So the first thing I normally do in this sort of situation is I do a trace. So we're attempting to load tile set image, and that's just the file path, which is what we loaded earlier from the XML. And now what we need to do is loading this image. There's actually something slightly different going on here. We need to create a persistent loader object because we need to access the loader object later, unlike the earlier XML loading where we could just use a temporary variable. So what I'm going to do is I'm going to create this private member variable over here. We'll just call it m_loader. It's very simple. And it's just a loader object, which is quite different to the URL loader because it does a bit more stuff. In particular, it allows you to load images. So it's a bit more sophisticated than the URL loader, which basically just gives you a hunk of data. Well, this is a lot more interesting what it can do. So we're just going to call this our asynchronous loader object. And now we need to create it in our constructor. As soon as the constructor is called, we create this loader object. So in here, we just create a new one. It doesn't have any arguments. And now this is where it gets a bit crazy. We have to add an event listener, just like with the XML loading earlier. But we don't just do add event listener. We actually have to add the event listener to a different object, which is a member of the loader. And that's the content loader info object. It's got a pretty crazy name. All that it is a bunch of properties that represent what content has been loaded. One of those properties is a bunch of event listeners, and the one that we want is event complete. So very similar, just in a slightly different place to the URL loader. And like before, we need a function. So I'm just going to call this function onLoaderReady. So that's the name of the function we need to create next up. So when I save, it's going to have a little red thing, but that's fine. We'll fix that in a second. And like before, we need a URL request. So I'm just going to call it file request. We don't need to store this one as a private member variable because it's all just a temporary object. So we just create a new URL request and we give it the path of that file, which we had earlier, m_file path. And then as usual, we just do the load. I'm not 100% sure why the ActionScript developers chose to make images load so differently to other types of files. Presumably loader is some sort of subtype of the URL loader or something to that effect. But it's loaded in a very different way, and I'm not 100% sure why that it has been done like that, but that's the way we do it, so it's not too bad for us. All we need to do is now provide that little member function, and we will be able to load our image in there. So that's just a private function, and we paste the name from earlier. Oh, it's not on my clipboard anymore, we'll just put it right in. And once again, it's just taking an event as an argument, and it doesn't have any other, it doesn't have a return value. But no, it's not working very well. Alright, so this is called when the image file has finished loading. And in here, this is where things get a bit more interesting because we need to actually extract the image. So our image is in here. It's automatically been loaded for us already when this is hit. We just have to pull it out and put it into this bitmap data object over here, which we can then use further on. You'll see what we do with that later, but it's very important that we have access to this bitmap. So all we do is we assign it through the magic of ActionScript's internal casting. We can just assign a bitmap object. So let's start it from a slightly different tack. We're going to need to do a bunch of stuff here. So we're going to do it from the inside out. So first of all, our object is in evt.target. So that right there is a binary hunk of data which represents our bitmap. So what we need to do is we need to package that up into a loader info, like so. Now when we construct this loader info object in line like this, it's actually going to look at that data and decide, okay, this is a bitmap or this is a sound or whatever it is. It can load a number of different types. That loader info is what we use to leverage this data and turn it into a type that we can really work with. So loader info, once it's created, will contain a content member. So just over here, if you see I'm adding the content, so that content is a member of this object that's just been created in line right over here. And this content actually contains our bitmap too. So there's a number of other properties here, so it's not actually auto-completing it for me, but there are a number of other things in there. So all you need to do now is create a bitmap object inline once again. So we're doing inlines of inlines, which is quite interesting and sort of a one-liner. It could be a bit more complex than this, but I just like to put things on one line. It's very much easier to read. So now when we create that bitmap object using the data that we pulled out previously, we only have a bitmap, but what we really want is a bitmap data, because pretty soon we're going to be going right into the pixel level and grabbing things in there. So bitmap won't help us with that. You can only draw a bitmap. You can't actually access individual pixels of it. So bitmap is a bit of a higher level class, and bitmap data is very low level, which you'll see why we need it soon. So what we want to do is each bitmap actually has bitmap data member, and that's what we want. So we take that. That's our final bitmap object, which we can actually assign into our image. So we're just basically saving a reference to an object that's been temporarily constructed on the fly for us. And as soon as this line is over, all these loader info things are going to be taken back by the garbage collector, and we'll be left with a reference to the bitmap data, which is very interesting for us. Now I have a little red mark here, and that's because I haven't got an import statement. So it wants loader info and bitmap. So let's just add those. I wasn't using autocomplete there. So I'm just going to add those in manually, just because I wanted to explain how it works. So we need bitmap, and we also need flash.display. I'm not actually sure which one loader is. Let's just check what it's saying now. Oh, loader info, that's the one it wants. So it's very similar to loader. There we go. Just in the same package. And now we've got rid of our arrow. So it's really easy. I mean, it's not very difficult. I mean, let's do a trace. If this worked, m_image should have a bunch of properties. You can see m_image, which is a bitmap data, has a lot of stuff in it that you can do. You can get pixels, and you can pretty much do anything you like with this bitmap. And one of the most interesting attributes it has is the width and the height, which indicate the width and the height of the source image. So that's the width and the height of this bitmap right over here. So they should be right after all that we've gone through. So we can trace that just to make sure and test it. So we can say that it's loaded the image, and then image file name, which is just file path. And now we can say width equals, and the width of the image, width just like that, and the height. I know this is getting a bit long, so I'm going to, just for clarity, I'm going to move it onto a couple of different lines. Height equals, and the image has a height member too. Very straightforward. And now if we go back to tilemap, just to review, for each element, it's going to be creating a new tileset object, which in turn will construct tileset right over here. And once tileset is constructed, it fires off a loader, which eventually, if it succeeds, it's left as an exercise for the reader to handle errors. But if it succeeds, it calls this method. Then it converts the event target data, which contains the file in the binary form, into a bitmap data object, which has a lot of things we can do with the pixels. And then finally, it outputs the width and the height of that image that it loaded, which indicates to us that it was successfully loaded, and we can start manipulating it. So let's try it out and see how we go. And yeah, I just select always terminate if it pops up this message. Eclipse in general is not very good at cleaning up old debugging sessions, and personally to me, I'd be very happy if it just only ever allowed you to launch one thing at a time like Visual Studio does, but that's just Eclipse for you. So let's go back and have a look at the log and see what happened. And I'm very happy because it's loaded the image. So as you can see here, it's loaded tilemap.png, width 72, height 24. That means everything is working. And if we look back at our image, the dimensions are 72 by 24. That means all the bitmap data is there and it's ready for us to play with. So what I'm going to do now is I'm actually going to stop running and terminate everything. Oh, okay, it's already stopped for me, so that's fine. So I'm just going to kill it. So now that we've loaded this image and we've created a tileset class for each element, all we need to do is just store these tilesets. So there may be a few of them depending on the level. So we need to future-proof ourselves. We're going to store a bunch of these tilesets in the tilemap object. So that's sort of their parent object. Previously, you saw how we created the tileset object. All we need to do now is just save them. So what I'm going to do that is I'm going to create a dictionary object. And we're just going to call it m_tilesets. And it's a dictionary, just like that, auto-complete it. And the dictionary takes a little bit of explanation because it's not a class that many ActionScript programmers use all the time. What a dictionary is really simple concept. Internally, it's actually quite a complex thing that it does, but it's basically a bucket in which you store objects using a key to represent them. And then when you want to come back later and find the objects, you need that key again, and it associates that key with a particular object. So this is really easy to use. The very first thing you need to do before you're allowed to use it, before you can do anything with it, is to create one. So just over here in our constructor for tilemap, we're just going to create it. So the tilesets object is equal to a new dictionary. So that creates a new dictionary. That's just an empty dictionary. And now we can start populating it with what's in the XML file. So for each of these new tilesets objects we're creating, we actually want to add it to the dictionary. And that's really easy. All you do is you just use the bracket operator. And what the bracket operator does is it says, find me a slot given a specified key, and we'll be specifying the key in a second, where I can stick this object, which in this case is a tileset. So you can put any type of object into a dictionary. It's pretty flexible. It's very forgiving, and you can also use any type of object for a key. But as with everything, certain things have their caveats. So if you use very big objects for the key, that's going to be a performance hit. You want to use a very small object preferably a string or an integer for the key. The size of the object that you place into the dictionary as opposed to the key can be anything. The bigger the object, the better, really. It doesn't matter how big that is, but the key size is quite important. So for our key, we're going to use the file name. So we're going to be able to look up these tile sets just using their file name, which will be really handy. Like if you have 50 tile sets, the dictionary is going to have very high performance, and it'll be really easy to find things just based on their file name, which is actually what you'll see we'll be doing later on. So by using the bracket operator, we've created an expression that in fact gives us a slot. So we can assign into this slot. So this represents which slot we're going to be putting our thing in. We'll just bring it up in there just to make it clear. So we do it from right to left, and the new tile set object is created, and then it gets assigned to the slot in our dictionary, which is indicated using a string key, which is the file name. And later on, we can use this exact same expression as the left-hand side of a different expression. So I'll show you how to use that. So we can essentially put things in and take things out of this dictionary. It's very similar to a list, but it's a much higher performance if you're just looking things up. Now we need to create a class to represent the tile element. So that's this element in the XML file. We want to create a class to represent each one of these guys. We're going to be using that later on. So that's really straightforward. Just like before, we go into our tile map package. We add a new class. We're just going to call this one tile params. So these are the parameters of an individual tile, which we can place in our map later on. So the only argument that you need is the parent tile set and the XML object, because we're actually going to be parsing the XML object separately inside here for reasons that will be explained. It will become clear a little bit later on. So we don't want to have too many arguments to this constructor. So all we need is the parent, which is a tile set, and the XML element, which we're going to be parsing, which is just an XML object. So what's going to happen is all of this stuff is actually going to be parsed by the tileset param object itself. So this is a slightly different method than the parent parsing it and eventually creating an object. So this object's already being created, but it sort of does its own loading to a degree. And now all we need to do is just create a member variable that matches each of these XML elements in here. So there's a bunch of them. So I'm just going to go through that really quickly.